Good morning, good afternoon, and good evening, philosophers. I'm Professor Benjamin Smart, and this is the first in our series on philosophy of science through the lens of medicine. Let's begin with a thought experiment. Every morning you wake up, you get out of bed, and your feet stick to the floor rather than floating gracefully up to the ceiling fan. Because this has happened literally every single day of your life, you automatically infer two things. First, that everyone is probably having the same basic gravity-based morning routine. And second, that tomorrow morning you're unlikely to wake up hovering 3 feet above your duvet like a philosophical balloon. This kind of reasoning, from particular past cases to broader generalizations or future predictions, is called enumerative induction. It has the basic form: every observed x has been y, therefore all x's are y's, or all x's are probably y's. Or perhaps future x's will be y's, or future x's will probably be y's. There's sort of a variation on a theme there. So, for example, you might think that every swan you've seen is white, and therefore all the future swans you observe will be white. You might think that every time you've dropped your phone, it's fallen down, so the next time you drop your phone, it's going to fall down. Every Monday morning lecture has felt slightly too early, so next Monday morning lecture will probably feel slightly too early. Now, this seems perfectly sensible. In ordinary life and in science, we rely on this kind of reasoning constantly. But there is a lurking problem. The fact that something has happened repeatedly in the past doesn't logically guarantee that it'll happen again in the future. It's logically possible that the future will stop resembling the past, that the laws of nature could change overnight. Gravity could, take a sabbatical. Your coffee could fall upwards. It would be deeply inconvenient, but not, strictly speaking, a logical contradiction. So here's the philosophical problem. If inductive reasoning can fail, why are we ever justified in relying on it? This question is known as the problem of induction, and we'll return to it in more detail in a future video. But for now, I want to understand the machinery of induction by looking at one of its closest relations, causation. In philosophy of medicine and public health, distinguishing between causation and mere correlation isn't just a neat intellectual exercise, it's a matter of life and death. Roughly speaking, event X causes event Y when event Y happens because of event X. Event X is merely correlated with event Y when X and Y happen together a lot, but one doesn't happen because of the other. One doesn't produce the other. For example, smoking causes lung cancer, and that's one of the most important findings in the history of epidemiology, as you probably know. It's saved countless lives, but alcohol consumption is also correlated with lung cancer. Now, the thing about alcohol consumption is that whilst it's correlated with lung cancer, it doesn't produce lung cancer. You see, the thing is, when people get drunk, they tend to smoke a bit more. And so heavy drinkers tend to smoke more. And so since smoking does cause lung cancer, drinking a lot tends to produce more people with lung cancer. Once you adjust for smoking, the apparent relationship between alcohol and lung cancer largely disappears. And of course, this is really important because when you identify a real cause, you can intervene. If you make a mistake and you think what is really a mere correlation is in fact a cause, you can waste a lot of time, a lot of money, and possibly lives solving the wrong problem. And this brings us to David Hume. So, if you don't know, David Hume was an 18th century Scottish philosopher who coined the phrase, "proportion your beliefs to the evidence." He was one of philosophy's most important empiricists. Empiricists believe that knowledge ultimately derives from experience, and Hume, being Hume, took this idea and pushed it until it started making everyone rather nauseous. He argued that the contents of the mind can be divided into two kinds: impressions and ideas. Impressions are our direct, vivid experiences of seeing things, hearing things, touching things. So if I go to a cricket match and I see A.B. de Villiers hitting cricket balls, when I'm actually there watching A.B. de Villiers hitting cricket balls like I was a few years back, those are my impressions of de Villiers hitting cricket balls. Impressions of the images in my mind, the live images in my mind whilst I'm actually watching are the impressions. And I'm also getting impressions of the sound of his bat hitting the cricket ball, and so on and so forth. Ideas are less vivid than that. Ideas are your kind of imaginings and your rememberings. So when I look back to when I saw A.B. de Villiers hitting cricket balls, I have a sort of a fainter image, a memory. And sometimes my mind plays little tricks and gives me fake memories, but these memories aren't quite as vivid as when I first experienced them. Hume's famous copy principle says that every meaningful idea must ultimately be traceable back to some prior impression. If you have an idea of a golden mountain, that's because you've experienced gold and you've experienced mountains, and your mind has kind of combined them. That's a complex idea that's been built out of simple ideas. If you imagine a purple elephant, that's because you've experienced purple and you've experienced elephants. Quite simple, really. So Hume applies this general principle to causation. Now, when we say that one thing causes another, we usually think we mean more than just mere sequence, right? We think that there's necessary connection between the two events. The cause somehow produces the effect. It makes the effect happen. So Hume asks, where does this idea of necessary connection come from? To answer that, let's look at his most famous example, billiard balls. Billiard balls are snooker balls or pool balls or, billiards is a game just like that. Imagine one billiard ball or snooker ball rolling across a table. It strikes a second billiard ball and the second ball moves. Very ordinary, very familiar, very pub adjacent. Now, ask yourself, what do you actually see? You see the first ball moving, you see it make contact with the second ball, and then you see the second ball move. But do you see the necessity? Do you literally observe some mysterious causal glue passing from the first ball into the second? Do you see the mustness of the second ball's movement? Hume says, no, you don't. All you ever see is one event followed by another. Motion, contact, motion. The idea that the second ball had to move isn't something you perceive in the objects themselves. So, if it's not in the objects themselves, where does it come from? Hume's answer is both brilliant and somewhat disturbing. It comes from habit. After seeing billiard balls behave like this over and over again, your mind becomes accustomed to the pattern. When you see the first ball moving towards the second, your mind automatically expects the second ball to move. And it's that feeling of expectation that's the internal impression from which the idea of necessary connection is copied. So the idea of necessary connection isn't copied from something in the objects, it's copied from a feeling, something in the mind. So, in other words, causation isn't something we directly observe out there in the world. What we observe is constant conjunction, events of one kind regularly followed by events of another kind. The necessity is supplied by the mind. That is classic Hume. It starts with a game of billiards and ends by quietly undermining the very foundations of science. And this is where causation links directly to induction. So when we reason inductively, we assume that patterns observed in the past will continue to hold in the future. We assume that because billiard ball impacts have produced movement before, they will continue to do so. Because fires burned us before, it will burn us again. Because smoking's produced disease, in many cases, it will continue to do so. But how do we justify that assumption? We can't justify it deductively because there's no contradiction in imagining the future changing. And we can't justify it inductively without arguing in a circle. To say induction has worked in the past, therefore induction will work in the future, is itself an inductive argument and very obviously circular. So Hume concludes that induction cannot be rationally justified in the strict philosophical sense. We rely on it because we're psychologically built to rely on it, but it's a habit of the mind, not a deliverance of pure reason. Now, at this point, it's important to introduce a distinction. So far, I've mostly been talking about enumerative induction, reasoning from repeated observations to a general rule or a prediction. Every observed raven has been black, so all ravens are probably black, and so on and so forth. But much scientific reasoning isn't just enumerative induction. Scientists often reason by what philosophers call inference to the best explanation. Inference to the best explanation works slightly differently. Instead of merely saying, I've observed this pattern many times, so the pattern probably continues, we ask, what hypothesis would best explain the evidence we have? This is sometimes called abductive reasoning. For example, suppose you walk into the kitchen and find flour on the floor, a chair pushed up against the counter, a mixing bowl on the table, and a small child looking unusually innocent. You don't reason, every time I've seen flour on the floor, this child has caused it, therefore all flour disasters are caused by this child. That would be enumerative induction, and also maybe slightly unfair. Instead, you infer that the best explanation for the evidence is that the child probably tried to make something, maybe a cake, maybe a crime scene. Science often works just like that. We observe a cluster of facts and infer the hypothesis that best explains them. One famous example comes from the development of germ theory, especially the work of Ignaz Semmelweis in the 1840s. Semmelweis was working in a maternity clinic in Vienna. He noticed a terrifying pattern. Women giving birth on one ward were dying of childbed fever at a much higher rate than women in another ward. The difference wasn't random. In the one ward, the births were attended by doctors and medical students. In the other, they were attended by midwives. Now, Semmelweis did not yet have modern germ theory. He didn't know about bacteria in the way we know now, but he noticed something crucial, that the doctors and medical students often came directly from performing autopsies in the morgue to examining women in labour. The midwives didn't. After a colleague died from a wound sustained during an autopsy, with symptoms very similar to childbed fever, Semmelweis formed a hypothesis. Perhaps some kind of cadaverous particles were being transferred from corpses to patients by the hands of doctors. Lovely phrase, cadaverous particles. Not one to use at dinner. Semmelweis, anyway, then required doctors to wash their hands with chlorinated lime solution before examining patients. This was the kind of 1840s equivalent of that sanitizer stuff we have. The mortality rate dropped dramatically. Now, notice what kind of reasoning this is. It's not simply enumerative induction. Semmelweis was not merely saying, in every past case where doctors came from the morgue, women died, therefore this will always happen. The reasoning was much richer than that. He was trying to explain a puzzling pattern. Why were women dying in one ward at a much higher rate than in the other? Why did the risk seem connected to doctors and medical students rather than to midwives? Why did the colleague's autopsy-related death resemble childbed fever? Why did hand-washing reduce mortality? The hypothesis of transmissible infections material explained the facts far better than the alternatives available at the time. This is inference to the best explanation. Later germ theory, developed through the work of figures like Pasteur, Koch, and others, provided a more systematic explanation. Many diseases are caused by microorganisms that can be transmitted between people through contaminated instruments, environments, or hands. Germ theory was powerful because it explained more, predicted more, and allowed more successful intervention than its rival theories. This is one of the major strengths of inference to the best explanation. It helps us move beyond mere pattern recognition towards explanatory understanding. But Hume's problem doesn't disappear. Even inference to the best explanation depends, in the background, on assumptions about the world's regularity. We assume that the explanation that worked yesterday will probably work tomorrow, and that similar causes will produce similar effects. So whether we're doing simple enumerative induction or sophisticated inference to the best explanation, we're still relying on habits of reasoning that Hume thought couldn't be justified by reason alone. And that leaves us with a wonderfully uncomfortable conclusion. Science depends on induction. Medicine depends on induction. Public health depends on induction. Frankly, your decision not to step in front of a moving bus depends on induction. And yet, according to Hume, induction rests on a foundation that reason itself can't fully secure. This doesn't mean science is useless. Hume wasn't telling us to stop doing experiments or stop washing our hands or settle all disputes with billiards. He accepted that human beings can't help but reason inductively. It's literally a part of our nature. But philosophically, he showed us something that we take to be obvious, learning from experience, is far more mysterious than it first appears. So, in this video, we've seen three key ideas. First, enumerative induction moves from repeated observations to universal generalizations or predictions. Second, causal reasoning, which doesn't actually involve necessity in the objects, as we would probably automatically assume, but largely involves observing consequent junctions of events of one type followed by another, combined with some kind of habit of the mind. And third, that much of science relies on something called inference to the best explanation, where you look at a whole series of events, a whole bunch of evidence, and try and come up with the best theory that explains those events. In the next video, we're going to look more directly at the problem of induction and at certain preferred solutions to the problem. and we'll see whether any of those solutions actually work. But, spoiler alert, philosophers have tried, as we always do, and whether they succeed or not is generally a matter for debate. So that's all for next time. Thank you for watching, and I'll see you on the next one.